For this unit, we're going to be talking about chemistry of life. And one of the most important molecules that we're going to be talking about, even though it's not even an organic molecule, is water. Now, it's really easy to take water for granted. And even when we are in a position to be thinking about it, even then, it can be really hard to appreciate or even understand just what it is that makes water such an important part of the chemistry of life. This week, we're going to be talking about not only organic molecules, but how the chemistry and the structure of molecules plays an important role in how they function and how they power life's vital processes. But to understand any of that, first, we need to talk a little bit about water. You likely don't stop and think about just what it is about water that makes it so special and so vital to the chemistry of life. At its core, water is a molecule that is made up of a single oxygen atom and 2 hydrogen atoms. This seems like a rather trivial fact, something just to memorize. Oh, yeah, water, H2O. But it's actually this chemical makeup and how these atoms sit together that actually lead to many of the properties that make water the important ingredient to life that it is. Water is what is known as a polar molecule. This means that because of the way the electrons in the outer shell of the atom sit, the number of them, it's not just random where these 2 hydrogen atoms attach to that oxygen atom. In fact, they have a very predictable geometry that you can see reflected in standard images of what a water molecule looks like. Now, this isn't a chemistry class, so we won't be getting into some of the really nitty-gritty details of this, but the important thing to know is that water, you notice that it doesn't have a straight line. It forms this little angle with the 2 hydrogen atoms sticking out at an oblique angle of just about 104 degrees from that central oxygen molecule. This fact is fundamental to all of water's properties. Because of where these atoms sit, it means that there's different numbers of electrons in different parts of the molecule, which means that one end has a partial negative charge and the other has a partial positive charge. This means that it can, for lack of a better term, stick to other molecules in particular ways. It's because of this that water is what's known as a universal solvent, or a near universal solvent. Ionic compounds like salt, or more complicated molecules, such as, you'd guess it, the biological macromolecules that make up our bodies and all of the processes of life. This shape of the water molecule also leads to other properties. Let's take a look at ice. When you put an ice cube in a cup of water, it floats. This seems really obvious, but it's actually incredibly unusual. Most substances, when they are in their solid state, are denser than their liquid states. If you were to take, for instance, molten iron and then try to put a piece of solid iron in it, that solid iron would sink to the bottom before probably melting itself. This is because in general, molecules in the solid phase of matter are packed more densely. But because water has this weird bend in it, it means that when it is packed into a solid, when it goes from this free-flowing form that it is in the liquid stage, where the molecules are all kind of bumping into each other but then drifting apart again, when they start to pack into this lower energy solid, they form predictable patterns. And even more unusually, because of the way their molecules are shaped and the partial charge that's at each end, there's a lot more space in between them in this phase than there would be at the liquid level, which means that frozen water floats. This has really important consequences for the evolution of life. If we lived in a world where ice sank, every winter the top levels of the oceans would freeze. It would sink to the bottom, and it just wouldn't melt again. And life would not be able to continue under the ice sheets as it does in real world aquatic systems. And very quickly, this would lead to the extinction of basically everything. It seems like a rather trivial fact, but it's actually pretty fundamental to why water plays the role it does in our biosphere. Another consequence is that it actually takes a pretty large amount of energy to transition water between its different physical phases. It takes comparatively a lot more energy to melt ice into liquid and to boil liquid water into water vapor. Again, this comes from that arrangement of the atoms into the molecules and the charges that then influence how multiple molecules of water in a area can move and react in the arrangement they take. Because of this, water is actually really good at moderating temperature. We see this firsthand with where we live here along the coast. Most of you may think, in general, coastal areas tend to have a much more moderate seasonal cycle. They don't get quite as cold in the winter or quite as hot in the summer. This is because the presence of a large body of water nearby means that a lot of that energy that would go to heating up the ground instead is going to heat up this water that does not heat up effectively. Similarly, when it's cold in the winter, that water nearby continues to stay at a higher temperature, which then warms the environment around it. This also applies within our living bodies. Since we are, in fact, mostly water, this means that even for organisms that don't actively moderate their body temperature, things that are ectotherms, like snakes and lizards and frogs and all sorts of invertebrates, it means that if they go outside and it is 0 degrees Celsius, it is the freezing point of water, they're not going to freeze solid instantly. It's going to take a while for that liquid in their body to actually cool down to the point where it's going to freeze solid. Because of these strong hydrogen bonds, that attraction from that partial charge on each end of the molecule is called, because a lot of what drives that is the position of where those hydrogen atoms are. Water has a couple other really important properties. One is that water has a pretty high surface tension. You can look outside and see this in action on any puddle or stream. When you can look and see water striders and other insects that can literally walk along the surface of water. This is because it actually takes quite a bit more energy than you would expect for a physical object to break those hydrogen bonds and fall into the water. Just kind of mind-blowing when you think about it. This is superhero stuff here. Because of this, water molecules, when they're near each other, they tend to stick together. This is called cohesion. And they also tend to adhere to other substances and objects. This is called adhesion. Now, this isn't just a really cool trick for insects. This means that water exhibits a property known as capillary action. If you were to put water in a narrow tube, there's enough surface tension and enough bonding to the material of the tube itself that it is drawn upwards against gravity. This is how organisms move water and all of the attendant molecules within it through their bodies. It's part of what draws blood through your capillaries. Although obviously you got a pump there that's helping that out. It's what draws water from the roots and under the ground to the tops of trees, including the tallest trees, the redwoods. This really simple fact means that water can actually flow through organisms and transport all of these molecules that are required to stay alive. If it didn't exhibit this, organisms could never get very big because they would be limited by that water would move without, resorting to some other pump. It would take a lot more energy to stay alive if water didn't have this property. These properties that we've covered in this video, part of what makes water such an integral part of the chemistry of life. In our next 2 videos for this unit, we'll be building on this to discuss the actual molecules that form living things. While water itself may not be alive in the same sense as the structures of our bodies, it plays a key role in keeping us alive.